Hi, today we are going to explore one of the most important algebraic identities in math, that is a plus b whole square. But what does it mean actually and why it is useful? Let's break it down. It is called the algebraic identity for the square of a binomial, right? Or in simple words, it is square of a sum identity. It shows how to expand the squares of a binomial expression. Now, one question you may have, what is binomial expression, right? So, it is an expression in mathematics that has two groups of numbers or letters joined by a plus or minus sign. In our case, the binomial expression is a plus b. Okay? So when we say a plus b whole square, we are squaring a binomial, right? That means multiplying it by itself. So we are multiplying a plus b by a plus b only, right? Because there is a power of 2. So we are saying that a plus b is multiplied by a plus b itself, right? When we say 2 to the power 2, we say that 2 is multiplied by 2. In the same way, if we replace 2 by any binomial expression, then we have the same formula, like a plus b to the power 2 is a plus b multiplied by a plus b itself. Okay? Now let us use the distributive property to expand it further. So a plus b multiply by a plus b. In this case, we need to multiply a with a plus b, then we need to have a plus sign, then multiply b with a plus b, right? So the expression will look like, here you see a is multiplied by a plus b, then a plus sign, and b is multiplied by a plus b, right? So when a is multiplied by a, we get a square, right? Then when a is multiplied by b, then we get ab or a multiplied by b. Because we have a plus sign here, I will add a plus sign, right? After that we have plus, I will write plus. When b is multiplied by a, we get it ba, or we can write it as ab, right? Then we have a plus sign, I will write a plus sign, and when b is multiplied by b, we get b square, b to the power 2, right? See, this is what we get. Now we need to add similar terms, so a square will remain as it is. ab plus ab is nothing but 2ab. After that we have b square, right? Okay, so the final identity becomes a plus b whole square is equal to a square plus 2ab plus b square, right? Now let us take a real example to understand it better. This is the formula we have. A plus b whole square is equal to a square plus 2ab plus b square. Now let us say at the place of a we take 3 and for b we take 5, right? So first step, I am using a basic mathematics where a plus b whole square, I need to find it out. For a, I will write 3 plus 5 whole square is equal to 5 plus 3 or 3 plus 5 is 8 to the power 2. This is nothing but 8 multiplied by 8, that is 64, right? Now let us take the identity. Now I have to apply the identity, and we are going to solve it by putting a plus b in this formula, right? So we know that a plus b whole square is equal to a square plus 2ab plus b square. A square is nothing but 3 square plus 2 multiplied by a is 3 multiplied by b is 5 plus b square, that is 5 square, right? 3 square is 9 plus 2 multiplied by 3 is 6, 6 multiplied by 5 is 30 plus 5 square is 25. So this is, I write 30 first because this is simple to calculate, and plus 25 plus 9 is 34, and this is nothing but 64, right? So the identity works perfectly, right? Now you might wonder, does it work for subtraction also? Yes, but with a small change. Okay, when we say a minus b whole square, we are squaring a binomial, right? That means multiplying it by itself, like we had seen in a plus b whole square. Now in this case we have to multiply a minus b with a minus b, right? Now let us use the distributive property to expand it. In this case I have to multiply a with a minus b, then we will have a minus sign. After that we are going to multiply b with a minus b, right? So when a is multiplied by a, we get a square minus a multiplied by b is ab, then we have this minus sign. B multiplied by a is ba or ab, both are same. Then b multiplied by b is b square, but here this minus sign, when multiplied by this minus sign, it will become a plus sign, right? Minus multiplied by minus is equal to plus. This is we have seen in my earlier videos. Okay, so this is what we get, a square minus ab plus b square, and this is nothing but, after solving it, we get it, a square minus ab is minus 2ab plus b square as it is, right? So the final identity becomes a minus b whole square is equal to a square minus 2ab plus b square. Here only 2ab is in minus sign and rest a square and b square are positive, right? Okay, let us quickly try an example. This is the formula, a minus b whole square is equal to a square minus 2ab plus b square. I consider a equal to 7 and b equal to 2, right? Let us use the basic math where I am going to put in a bracket a minus b whole square. For a I am going to put 7 and for b I am going to put 2 whole square. 7 minus 2 is 5 whole square is equal to 25, right? 5 square is nothing but 5 multiplied by 5, that is 25. Okay, now let us apply the identity. We know the formula, a minus b whole square is equal to a square minus 2ab plus b square. A square we have 7 square because we have considered a as 7 and b as 2, right? Then minus 2 multiplied by a is 7 multiplied by b is 2 plus b square, that is 2 square. Okay, 7 square is 49, 7 multiplied by 7 is 49, minus 2 multiplied by 7 is 14, 14 multiplied by 2 is 28, plus 2 multiplied by 2 or 2 square is 4, right? 49 plus 4 is equal to 53 minus 28, right? This is equal to 25. 53 minus 28 is 25. Okay, so again the identity holds true for subtraction also, right? Okay, to sum up, we have seen that a plus b whole square is equal to a square plus 2ab plus b square, and a minus b whole square is equal to a square minus 2ab plus b square. We have seen relevant examples also. So these identities help in mental math, algebraic simplification and solving equations faster. Keep practicing with different values, right? And I will explain more examples in my next video. Thank you for watching.